Good morning, children. Welcome to online physical science class. Welcome to online physical science class for standard 7. This is chemistry lesson 6, metals and non-metals. So, on the basis of general properties, elements are often divided into two classes, metals and non-metals. More than 115 elements are known today. Of this, 24 are non-metals and most are metals. There are some elements whose properties lies between those of metals and non-metals. They are known as metalloids. Let us discuss some general properties. Metals are in general hard and strong. Examples are potassium, calcium, sodium, magnesium, aluminium, iron, zinc, tin, copper, mercury, silver, gold, and platinum, etc. Okay, children. Metals, the properties of metals are metals have a lustrous known as metallic luster. Okay, they are lustrous, that is they are metallic lustrous, that is they shine, the metal shines. Okay, that is called lustrous. Also, metals are generally hard and strong. Metals are generally hard and strong. So, in order to carry heavy metals, heavy loads, these metals are used. For example, the steel cables are used to carry heavy loads. They have high tensile strength. This having a high to bear heavy loads, no, that is called a tensile strength. Okay, tensile strength, and because of this tensile strength, they are used to carry the heavy loads. Okay, children. So metals have heavy tensile strength, and metals are sonorous. What do you mean by sonorous? When they struck, they are able to produce sound. Okay, they are able to produce sound. So in the case of this tensile strength, there are some expectations. There is expectations. They are sodium and potassium are soft solids. They can be cut with a knife, and mercury, which is also a metal, but it is a liquid under normal conditions. Okay, and metals are sonorous. So when you struck the metals, it will produce sound. Okay, and think over your doorbell. This is also made up of metal ion, right? Yes. Metals have high density. Metals have high density. That is, the metals are the density of some metals are given here. Iron 7.9 gram per centimeter cube, copper 8.9 centimeter gram per centimeter cube, gold 19.3 gram per centimeter cube, platinum 21.45 centimeter gram per centimeter cube. There are some expectations for exceptions. They are potassium, sodium, magnesium, and aluminium. They have comparatively low densities. Okay, although they are metal, they have less densities. And metals have generally high melting point and boiling points. Their melting point and boiling points are high. Some are discussed here. Aluminium melting point is 660 degrees Celsius, and the boiling point is 2467 degrees Celsius. When you apply this much amount of heat only, aluminium will melt 660 degrees Celsius. At 660 degrees Celsius only, aluminium will melt. Similarly, at 2467 degrees only, it will begins to boil. Iron 1535 degrees Celsius, boiling point is 2750 degrees Celsius. Copper 1083 degrees Celsius, and the boiling point is 2567 degrees Celsius. So they have high melting and boiling points. Okay, and also these metals, um, like potassium, sodium, tin, and lead, they have comparatively low melting point, but they have high boiling points. Okay, for like potassium, it has 64 degree melting point and 774 degree Celsius boiling point. For sodium, it is 98 degrees Celsius melting point, and boiling point is 882 degree boiling point. tin, it melts at 232 degree Celsius and it boils at 2260 degrees Celsius. Lead 327 degrees Celsius, it will melt and it will boil at 1740 degrees Celsius. Exceptions are the liquid metals like mercury freezes at minus 39 degrees Celsius. It will freezes only at a minus 39 degrees Celsius and boils at a 357 degrees Celsius. Okay, and the metals are malleable. What do you mean by malleable? In other words, they can be beaten or rolled into sheet. You can convert them into sheets, or you can convert them into wires. That is malleable and ductility. We know about the silver foil, that is to decorate the sweets, and the aluminum foil to pack the food stuff. So all these are what metals. Aluminum and silver are metals, but they are, though they have high tensile strength, they are spread out into sheets and wires. That is called malleability and ductility. And malleability. And what about ductility? Not only as a thin sheets, they can be spread out into thin sheets. They are flexible and they can be drawn into very thin wires also. Okay, copper, silver, gold are easily, in jewelry making we know gold are drawn into thin wires, and similarly silvers also. Copper, in the case of electric wires, copper also drawn into thin wires, right? So that is called ductility. Then metals are good conductors of heat. Metals are good conductors of heat. So you know that our kitchen utensils are made up of metals only. That is, you know that copper bottom vessels will catch up the heat very easily when you compare with the other one. That is why our kitchen utensils are made up of metals instead of non-metals. And metals also are good conductors of electricity, or also good conductors of electricity. What do you mean by good conductors of electricity? That is, they allow the electricity to pass through them very easily. That is why aluminum and copper are used in making electric wires. Is it clear, children? So these are the general properties of metals. Now we are going to discuss about the general properties of non-metals. Among the non-metals, 24 are elements are non-metals. Among the 24 non-metals, 12 are solids, 1 is a liquid, and 11 are gases. Okay, so let us discuss what are their general properties. Solid non-metals are non-lustrous, that is, they don't have the shining nature. Dull looking, they are dull looking except graphite, because graphite, you might have seen graphite and iodine, they are lustrous, they have the shining capacity. Graphite is the one which is present in the pencil lead. Okay, then metals are hard, non-metals are not hard and have low tensile strength. Okay, exception is diamond. Okay, though non-metals are have low tensile strength, diamond has more tensile strength, and it is the diamond is the hardest solid in the world. Okay, and non-metals are non-sonorous. Non-metals will not produce sound when they are struck. Non-metals have low density. Also, non-metals have low density. So some of the densities are discussed here. Phosphorus with a density of 1.82 gram per centimeter cube. Sulfur density is 2.07 gram per centimeter cube. Graphite, that is the form of carbon, its density is 2.25 gram per centimeter cube. Diamond, it is also a form of carbon that has 3.52 gram per centimeter cube. So in the case of this density, though they have low densities, the non-metal bromine has high density. So it is a exceptional case. Okay, it is an exceptional case. Then what about the next property? The next property is they have low melting point and low boiling point. Okay, here some of the melting points and boiling points of some of the metals are discussed. So go through that. Some metals, see, now some non-metals have the melting point and boiling point even at -degree Celsius. So They have low melting point and boiling point. The exceptional case here is carbon. Carbon melts only at a high temperature, that is approximately 3550 degrees Celsius. 3550 degrees Celsius. Non-metals are brittle rather than malleable. You can't spread them into thin sheets. They will break up easily. And non-metals are ductile. Non-metals are ductile. Okay. They are not ductile. That is, you can't convert them into thin wires. Also, non-metals are bad conductors of heat and electricity. Bad conductors of heat and electricity. But graphite, expectation is graphite. Exceptional case is graphite, which is a good conductor of electricity. Okay, children. You can verify the properties of metals and non-metals through some various experiments. When you insert a wooden scale and a metal rod in a boiling point, you can and hold the rod and scale, you can feel the hotness in the case of metal spoon, but not in the case of wooden scale. This proves that metal is a good conductor of heat and scale is the bad conductor of heat. Okay, similarly in the case of electricity, you can make a simple circuit by connecting the wires and batteries, and the key should be a metal key. Okay, the key should be placed here. So when you place a metal key, the current will flow through the metal key and the bulb will glow. But when you replace the metal key with a piece of charcoal, the bulb will not glow. From this you can identify the metals are good conductors of electricity, whereas non-metals are bad conductors of electricity. So these experiments, simple experiments, proves you the proves you the properties of metals and non-metals. We also learned the expectation is that graphite will conduct the electricity, no? So you can replace in the same circuit by a pencil. The leads of the pencil should be connected to the wires, and we can see that the bulb glows there. This is because graphite, though it is a non-metal, it conducts electricity. Okay, children. Okay, now the next case is metalloids, that is semi-metals. These semi-metals possess both the characters of metals and non-metals. These metalloids properties are metalloids are hard solids. They may or may not have lustrous. They have densities intermediate between the metals and non-metals. Their abilities to conduct heat are intermediate between those of metals and non-metal, except some being good conductors of electricity. Metalloids are semiconductors. Okay, some metals that is metalloids like arsenic and antimony, they are good conductors of electricity, and metalloids like silicon and germanium are semiconductors. These metalloids like silicon, germanium are semiconductors. Their ability to conduct electricity is intermediate between those of metals and non-metals. The semiconducting property of these elements have made them highly helpful in the electronic industries. The chips used in TVs, computers, phones, etc. are made up of this silicon. We know about this silicon chips, isn't it? Yes. Okay, then now the next topic is alloys. What are alloys? Alloys are nothing but they are a mixture of metals. Okay, mixture of metals and non-metals. A solid solution, that is a homogeneous mixture of metal with other metals or non-metals, is called an alloy. It's a mixture of metals and non-metals. Okay, some examples of actually these alloys are stronger than the original metals. Some alloys and their constituents are discussed here. Steel is made up of iron and carbon. Steel is made up of iron and carbon. Okay, and also manganese. Stainless steel containing chromium and nickel. Okay, and manganese steel containing manganese and iron. And the various uses also discussed here. This manganese steel is used for making railway tracks. Stainless steel, utensils, cutleries, balls, etc. And what about the steel? Steel is made for making railway tracks. Okay, children. So these are the another one is brass. Brass is the alloy of copper and zinc. Copper and zinc, and it is used for making utensils, bullets, and musical instruments, etc. The next one is bronze. Bronze is the alloy of copper with tin, and it is used for making statues, medals, etc. Actually, the jewelry we are using making with gold, no, it's a alloy. It's a pure, since pure gold is very soft. We mix them with copper so that it have that tensile strength, and we use it for making jewelry. Similarly, when we make alloys of mercury, we call them as amalgams. Okay, we call them as amalgams. And silver and tin amalgams. When silver and tin are make the alloy with mercury, they are used in dentistries. Okay, children. So the next topic is uses of metals. We know all the various uses of metals: bronze statue, brass vase, things made up of stainless steel. All these are made up of metals alone. Apart from that, metals also used to conduct the electricity through wires. Aluminum, of course, it is used to make electric wires and food foils. Okay, and magnesium uh, is used to produce dazzling white light in the case of fireworks and flash bulbs, and similarly in coating the iron in order to prevent it from the rusting. Similarly, zinc also galvanizing. When you use zinc to coat the iron to prevent it from the rusting process, we call it as galvanizing. And mercury, we know that mercury is used in thermometers, etc. Isn't it? Mercury is used in thermometers for to find the temperature, etc. Lead, silver and gold for making jewelries. Platinum is also a white shining metal. It's a costly metal used in making jewelries. So the next topic is corrosion. The chemical action of moist air on metal is called corrosion. Okay, the chemical action of moist air on metal is called corrosion. In moist air, a piece of iron rust. Iron will rust. To prevent that, the rust is represented by the formula Fe2O3 X H2O. Fe2O3 X H2O. And when iron reacts with oxygen water, it forms rust. Oxygen and water, it forms rust, you know, isn't it? And place some iron nails in the ordinary water and boiled boiled and distilled water, and also place some oil over it and close it with a airtight rubber cork, and place it with a quick lime. In three cases, in the first case alone, the rusting will take place, because in second case and third case there will be no moisture and there will be no oxygen, so the rusting will not take place. Okay, children. So how to prevent this corrosion? Corrosion can be prevented by painting, by applying paints, galvanizing, greasing, by applying grease, galvanizing. Now only I have discussed, by applying a coat of zinc, electroplating. A plate, that is a metal can be plated over the another metal through by the supply of electricity. You will be reading in detail about this electroplating in your higher classes. And alloying the metals. So that is, instead of using iron, we can use steel. That is the alloy of iron. Okay, in these ways we can prevent the corrosion. That's the end of the lesson. Hope you have understood and enjoyed the lesson well, children. So do your assignment and report in the group without fail, children. Thank you. Meet you again.